Hello everyone. Today we are building a reaction diffusion effect. Actually, we are building more like the fake version of it. We don't build like the real chemical reaction diffusion. I don't want to go into detail how this effect really works. You find plenty of stuff online. If you want to go and dive deep, there is enough content for that. I highly recommend to watch this tutorial here from Entagma. It's they build it in Houdini, but the first part of their series, they go into detail and explain how this fake reaction diffusion effect works. And he also shows an example in Photoshop, and that's what I do with you too. And then we building this effect, what we built in Photoshop, we built this in C Notes. Okay, I'm here in Photoshop. It's in German, but I will explain, of course, in English. So what we are going to do here, every step we are doing here, we are recreating then afterwards in C Notes. So the idea is we have first to build our chemical here. To chemical, the first chemical here is black, and then we put some white chemical into the canvas. And first thing that we do is first blur it. So go to filter, and then we are using a Gaussian blur. So blur it around 4 pixels. Then we duplicate the layer and we blur this again, maybe another time. And then what we need to do is to subtract. So it's called subtract here, the layer blend mode. Subtract the second layer from the first layer. Then we merge those layers, and then we are using an exposure effect. This is an exposure effect. We up the exposure here to a high value, so we have kind of a hard edge here. And that's it for one step. And when we do this over and over and over, then we are creating this kind of reaction diffusion effect. So I already built here action for this, so we can play this action over and over and over again. So you can see here this nice pattern appears when we do this over and over again. And now what we are going to do in Cinema, we try to recreate all those steps that we did here with C Notes. Okay, I think we can start now with Cinema. So this is what we are building in Cinema. Here we are building a simple version here. So pretty similar to what we did in Photoshop. And afterwards I will show you my advanced version here. There are a lot of settings where you can play around. So we do this at the end of the tutorial. Okay, let's start with the setup. So first what we need is a canvas. So we keep it simple. So we make a plane. So because we need a lot of points, so the points are kind of our pixels. So maybe let's make 200 of 200. Then what we need next is our initial reaction to our initial chemical. So we built this with a vertex map. That's the easiest way. So vertex map, and then we are using fields. And let's make an initial chemical, maybe with a random effector, with a random field. Let's make this bigger here. And maybe something like this, and then also where is it? A curve. So to make sharp contrast here, so something like this. So, and this will be here our initial chemical. And then that's it here for the initial stuff. Next we need a capsule. So we built this with object group capsule. So type in group. So because we are building a solver, the memory solver, so the memory node here in 2024.1 is just working in the C node context and in the object group capsule. They don't work in the other nodes. So this will maybe work in the future, but we are using now an object group capsule for this because there the solver works. Okay, then let's jump into the capsule. Maybe rearrange the windows so we have some space. So, and what we need first is, of course, our initial canvas here, our plane. And then what we need from the plane here, from the geometry of the plane, we need the vertex map. So we can use geometry property get. And what we need here is weight. So weights are the vertex maps. So let's click onto the vertex map, maybe give it a good name, call it chemical, and then drop the vertex map in here. So now we have here an array with all the values of our vertex map here. So red will be 0 and yellow will be 1. What we need next is, because we want to blur those values as we did in Photoshop, and there is no blur function like the freeze field for the normal fields. So we have to build our own blur function. Blur function is actually pretty easy. It just every point has to look at his neighbor points, and then the values of all the neighbor points, we build an average, and this will be the new value of every point. So what we need is the neighbor points for all for every single point. So we can do this with our good old friend, the closest points. So then here we need the geometry, and then we need a query position. So this is every point. So we are using another geometry property get, and now we are using the point positions. So, and then we plug here the array. Here are all the point positions inside. Plug this into the query position, and it generates automatically an iterate collection for us. So it iterates over all the point positions. And then the closest point here, the selection string, we can add, or we say all, so because we want all the points. And then the maximum distance 100, that's fine here for this setup. And then with the maximum neighbors, we can decide how much neighbors we want to collect for every point. So we start with 20 points. And now we have here an array with, for every point, we have here an array with the 20 closest neighbors. So we have to collect those in a final array. So we use a sample collection here. Then plug this in here, and now we have to decide our array, our neighbor array. So it will be an array, And for the moment in our array, there are float values, but we want those neighbor indices here. So in our array, there is another array. And in this array, there will be integers. So we can click here and see, okay, it's an array with integers. And here we have also an array with integers. So that's fine. So, and now we can call this per neighbor array. So now, because we want to manipulate here our chemicals here, our chemical values, maybe let's call this chemical vertex map. We want to manipulate this on every frame, so we need a solver for this. This is called the memory node. And here for the initial values, you have to decide what is which values we want to manipulate over every frame. So we like to plug in here our chemical into the initial values because we want to update our chemical value over every frame. So plug here this into the type. So the first initial value knows what type it is. So it's an array here, an array with floats inside. Then we don't need the second one here, so we can remove the second input. And then also we like to have our neighbors inside of the solver. And then we can jump inside of the solver. So what we like to build first here in our solver is the blur function that I talked about. Because the blur function is also something that we like to do more than one time. So because different blur amounts give different results, we are building our blur function inside of a loop. And here we are passing into the variable 1, we are passing our, also make here set the type and then feed in here our chemical, maybe call this chemical array. And this one here, neighbor array. And we need a second initial variable. This will be our neighbors. I thought actually we could put the neighbors, feed in the neighbors here as normal input, but I don't know why it don't work because we don't have to manipulate the neighbors. But it don't work with this setup. Don't know why. So we have to pass the initial neighbors here also as an initial variable. Maybe here let's call them 2. Delete this one. And then we can jump inside. No, sorry. First here we have to decide how much it loops, so how much blur iteration we have. Maybe call this blur. We can do this with a range. So for the moment we just need one iteration, but we can change this afterwards. Plug then the curly bracket here to the other curly bracket. So now, because we have loop from the range from 0 to 1, we have one loop. So let's jump inside of the loop. Here inside the loop, we want to iterate over every point, so over every chemical value. So we use an iterate collection, feed in a chemical, and now we have here the every chemical value. And then we want to know for every point, we want to know the neighbors. So we use a get element, or put the index into here and then the chemicals here into the array. So now we have here for every point, we have here now our neighbors. And we also like to iterate over all the neighbors. So we use another iterate collection. We iterate here over the neighbors. And now we have here in the elements, we have the indices of all our neighbors. And then we need from every neighbor, we need the chemical value. So we use another get element, feed in our chemicals and then the element here into the index. And now we have here all the chemical values of all the neighbors for each point. Then we like to assemble all those values inside of an array. So another assemble collection. And this is an array with floats inside. That's fine. So close the loop here and then the values here into the assembly collection. And now we have here an array with all those values inside. And because we need the average of all those chemical values, there is a node called average. I think it's called array arithmetic. So we feed in here our array and then the operation is average, that's fine, and data type is float, that's also good. And then we have here, so the average value for every blurred point, if you want to say it like that. And then we have to collect all our new chemical values inside a final array. So another assembly collection. Close the loop here with the curly brackets, and then the values is also an array here with floats inside. And then here our new blurred chemical outside of the chemical output here. So this is now the chemical but blurred like we did in Photoshop with the Gaussian blur. And then finally the neighbors, they go here to the output. The neighbors, they will stay the same, but it just works if the neighbors are an initial input, not a normal input. I don't know why, but yeah, it works. Okay, let's jump outside of the loop here. And now we have here the blur number 1. And as I explained you here in Photoshop, we have first to blur it. Then we need a second layer, and this layer we also have to blur twice. So that's what we do. We just duplicate the blur loop here, and then the blurred chemical here, we put this in here, and now we have here it blurred again. So this one we like to blur 2 times, and now we have here the blurred chemical 1 here, and here will be the blurred chemical 2. So this is like our 2 blurred layers in Photoshop. And what we need to do now is to subtract one chemical from the other. So first we like to iterate over our chemical 1 here. Use another iterate collection. So we have here every chemical value of the blurred chemical 1, and then we use a subtract, and then we like to subtract the second one from the first one. Here, this one, we like to subtract the second one, so we can use a get element to get the value of the blurred here, of the blurred value 2. So feed this in here. Then the index in here, and then we subtract the blurred value 2 from the blurred value 1. So we like to say we subtract layer 2 from layer 1. Then we need our exposure effect. So this is pretty simple. It's just we have to multiply here this value with a strong value. So here maybe we can play with this, maybe say also 20, so we multiply it by 20. But then because we are our points have our values have to be always between 0 and 1, we have to clamp it also. So let's clamp the values between 0 and 1. And here the exposure, maybe let's make a parameter, so we can we have a parameter outside. We can change this afterwards. And also our two blur iterations. Blur 1 and blur 2. Okay, and now we have to do now for the final thing inside the solver, we have to collect our final values here. We use, of course, an assembly collection for this again. So close the loop here. And the values, again, it's an array. Oops. It's an array with floats inside. And this here is now our final chemical value. We can put this here into the next, and then we can jump outside of the memory. And the final thing we have to do here is our final value. We have to give this back into a vertex map. So we want our own vertex map for this to visualize it here. So we can use an geometry property set for this. So first it needs the geometry. And then we like to generate a weight. So we may like to make a new data set. So we want a new vertex map. Let's call this just vertex map, and then switch it to array mode, and then our final chemical goes here into the array, and the geometry here to the output. And now we have here, you can see on our capsule it generates a new vertex map. Maybe let's write this, and now let's build a material to preview it. Let's make a new material. Then add a vertex attribute. Then feed here our newly generated vertex map into the attribute name. This here to the color. And then of course onto the capsule. And I hope everything worked. So let's try and let's press play. Oops, something went wrong. So let me search for the error. Okay, I found the mistakes. First, when I copied here the geometry property get, here the name was still chemical, the name of the vertex map. So, but the point positions, it don't need needs a name. And the second one, I forgot to add to the second blur here the neighbors. So plug this in here. And now we can press play. And now everything works as expected. So yeah, that's it for this part. And now I like to show you the advanced setup. Okay, here this will be the file you can download. Here is the simple setup that we built together. It's the same, it's a bit more organized, but it's the same setup. And also here I made some parameters here. These are the parameters that we also built in the tutorial here. And here we have the main set, the advanced setup. So activate this. I have this here on a sphere. And here you can see I have first the input's the initial object, of course, this is the sphere. Then here you can decide if it is time dependent or not. So because I have here some initial vertex maps that they are changing over time, it has to be time dependent. So here is the first vertex map. This is our chemical. This is this one. So maybe let's have a look. This one is the initial one. I built this here with cube that goes up and just adds chemical then to the mix. And then here is a vertex map that I use for the exposure. So we can also have kind of different exposure values, not just a simple constant value. And then the third one here is also a noise vertex map for the neighbors. So we can decide how much neighbors the blur function has. So let's go back, and these are those initial vertex maps, the chemical one, the exposure vertex maps, and the neighbors. Then here you can, this is like in our simple version, the amount of the first blur, the amount of the second blur. So with you have a more detailed, maybe let's show this. You have a more detailed reaction diffusion. It's also the size will also be bigger if you have more blur amount, but of course the setup gets slower. So try to keep them low. Then here are the how much new chemical we like to add to the mix. So if we go high with this value, you can see it can't change because we always add new black and white chemical here to the mix. So it always refreshes. So try to make here small values. So we don't add too much so the reaction can develop. Then we have the exposure minimum, exposure maximum. So this is kind of the strength as I explained in the tutorial. So maybe when you go low here and high here, you have also different effects. You can see on some parts it develops fast, on another part it stays black. And then the same, of course, you can do with the neighbors. So maybe reset those first so you can see the effect here. When you have a small amount of neighbors, so maybe 20, and a higher amount of neighbors, you will see also the effect. Maybe let's make 35 here. You can see on some part it is kind of the diffusion is bigger, and here on some part it is smaller. So that means here in this area there are less neighbors, and here on the bigger parts there are more neighbors, so that the blurring effect here is stronger. And then here the last settings here is the post blur. So when we deactivate this, you can see it looks like it is pixelated here, like here in the simple setup. So that's simply a post effect. So you can do this also straight here in the vertex map, but I like to do this also in Node. So you can add a post effect. And of course say how much it has to blur. And then here the last settings is displacement. So we have a displacement where the vertex map is. This one you can do, of course, also with a normal displacer or with a plane effector, but I built this also inside of nodes. So you can decide how high displacement is, and also the exposure strength is because we have a different amount of exposure. Where we have a high exposure, it displaces more, and where we have a low value of exposure, the displacement is close to 0. This here is just a profile of the displacement, so it's not linear here. It's more like a beveled effect. So we zoom in here, make it linear, you can see what happened. So if here more linear effect, and here with this one you can decide how the displacement should look like. So yeah, that's it. And as always, the files you will find in the description. You can download them on Gumroad. And if you have questions or something isn't clear, let me know in the comments. And then I wish you a nice evening or morning or whatever. And bye-bye.